All right, in this video, we're going to look at relays and some of the different types of relays. So relays are used in industrial processes to control other components, whether that be lights or contactors, motor starters, alarms, whatever we want to use to control it. So a relay or control relay is basically a solenoid that has contacts that are attached to it, so that we control the current to the coil, and when we apply that current, that creates a magnetic field that changes the state of the plunger inside, which moves the contacts to open and close those contacts. So here we're going to look at some different types and different configurations, read the information that's on them to better understand how they work, and so you'll know how to use these. All right, so here's one type of relay, and I want to mention too that another name that you'll hear for these, some technicians will refer to these as ice cube relays, and that's just because of how they look. So they're in a cube shape, and most of them have this clear casing, which makes it look like an ice cube. Okay, so if you hear that term, it's nothing special, it's just another name for it. All right, so if we look inside here, we can see right here, this is the actual solenoid. You can see the plunger sticking up there, and that's what moves the contacts. So the contacts are across the top here. You can see those copper tabs going across and making contact with these metal tabs. All right, so down here at the bottom is where the coil connects. So on this one it's called A and B. And then 7, 8, and 9 is the common point of the contacts. So this relay has 3 different sets of contacts. And then these top numbers are where the contacts move to and from. Okay, so we have 1, 2, and 3, and 4, 5, and 6. So we're always going to use this 7, 8, and 9 for our power coming in, and then we pick which one of these top ones we want to use based on whether we want it to be normally open or normally closed. So if you look here, you can actually see that the contacts are touching the top. So the top connections are the normally closed contacts, because remember, when we say normal, that's the not activated or de-energized state of a component. So the top ones are the normally closed, and then you see a gap between the contact and the bottom one. So these bottom numbers are the normally open, so 4, 5, and 6. So if we're coming into 7, if we want it to be normally closed, we would come out of 1. If we want normally open, we would come out of 4. Okay, so that's how this one would operate. So if we look at the front here, it tells us information about the coil. So it's rated for 24 volts DC. So A and B, the coil, so the control circuit that this is used in has to be 24 volts DC. Okay, and then it gives us information about the actual contacts and what they can handle. All right, so how much current and voltage they are rated for. So the contacts can be different than what the coil is. So if I'm using 24 volts for the coil, the contacts could actually be using 120 volts AC to control whatever part of the control circuit we want to. That's not a common thing, but it can be done. Okay, so the coil voltage and the contact voltage can be different. Okay, so that's just one type. Here's another one by a different manufacturer. This one is 120 volt coil. So a little bit different configuration here than we've seen on this one. Okay, as far as how the pins come out to connect to the base of the relay. And here we can see a schematic of just how everything connects. So on this one, the coil is labeled as A1 and A2, And then again, we have 3 sets of contacts for this relay. So I'm just going to work my way around here. So 1 and 3 is normally open, and 1 and 4 is normally closed. So you can see what's touching and what's open tells you what's normally open and normally closed. So if I move to this one up here, 6 is the common. So if I connect out of 5, that'll be normally closed. If I connect out of 7, that's the normally open. And then this group, 11 is my common, and then 8 is normally closed, and 9 is normally open. All right, so you can see the contacts inside of there. You can see right here the coil. You can see it better on this side. So right there's the coil, there's the contacts. This is where the common side of the contact is wired to the pins. And then you can see the top here is normally closed, the bottom is normally open. All right, and you can see the 3 different sets up top here, okay, for this relay. All right, so a little bit different configuration, but still the same concept of operation. All right, so these two are similar. They only have 2 sets of contacts, but they look identical, okay? But the difference between these two is the coil. So if I flip them around where you actually see the coil, see the difference? So this one over here is a 24-volt coil. This one over here is a 120-volt AC coil. But other than that, these are identical, okay? So these actually have different indicator lights in these to show you when the coil is operating. So I have 2 sets of contacts here. So 5 and 6 are my common, and then I pick between the tops if I want normally open or normally closed. So 5 and 1 is normally closed, 5 and 3 is normally open, 6 and 4 is normally open, 6 and 2 is normally closed. Okay, so again, just reading these schematics and understanding what's normally open and normally closed. So you see that this schematic is much different than what this one shows, but you have to be able to read these to understand how they operate. Okay, so these two are similar as well. Okay, so looking at them externally with their shape, they look the same. But again, if we compare and look inside here, we can see that this is a 24-volt coil. This is a 120-volt coil. These have 4 contacts on them. Okay, so if I look at the front here, I can see the information. Just set this one down where I can look at this, just the one. So 13 and 14 is the coil, and then I have the common point of each contact, which is going to be 9, 10, 11, and 12. And then up here I can pick between normally closed and normally open. So 1, 2, 3, and 4 is the normally closed. 5, 6, 7, and 8 is the normally open. Okay. So I have 4 contacts on this one. And it also states here that the coil is 120 volts AC. And on this one, the coil is 24 volts DC. All right. So on each of these, they have the pins that come out. They can be in different configurations. And that's what plugs into the base. So this is the base for this relay, which plugs in like that. And then I have the screw terminals, which I can strip my wire and connect to, okay? And there's a specific base for each type of relay. So that's for the 4-pin. This one is the smaller one for the 2-pin, or the set of 2 contacts, I should say, okay? So there's a specific base for each one of these. So this one's actually open here, so I just want to show you if I can get it apart. Yeah, there we go. Where I can show you more details about this, so I can actually physically move the contact. Okay, so you can see the top's normally closed. If I push it in, the top contact's open and the bottom ones connect. Okay, so you can see how the relay actually works when the coil energizes and creates that magnetic field and pulls those contacts down when I energize the coil. Okay, so again, this is the 4 contact. So I got 4 different sets I can use to control different components. And again, this one is the 24-volt coil of the relay. So that's these connections down here, which is what the coil connects to. All right. So one other thing I want to point out is you do have to pay attention to the base here of these, because sometimes it doesn't line up from what the diagram shows. So I want to show you, for example, right here. Okay, so let's look at the coil. This is 13 and this is 14, right? If you look down on the base, this is 14 and 13 is over here, which is opposite of the relay. Okay, so oftentimes it's a direct relationship as far as physical location, but sometimes it's not. So you have to pay attention to these labels on the actual relay of what these numbers are. So 9, 10, 11, 12, and here it goes the opposite way, left to right, 9 through 12. Here it's right to left, 9 through 12. So pay attention to that too on the actual relay so that you wire it properly. All right, so that's just a little introduction to control relays and how they work, how to read the diagrams, and hopefully this helps you with making the wiring connections with these.